Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0119, indicates an issue with the Engine Coolant Temperature, ECT Sensor 1 circuit, which is out of range. The ECT sensor is a critical component in monitoring the temperature of the engine coolant. It provides information to the Powertrain Control Module, PCM, to optimize engine performance and fuel efficiency by ensuring the engine runs at the correct operating temperature. The ECT sensor is typically located near the thermostat housing in the engine bay, making it accessible for visual inspections and repairs. When this DTC is triggered, it typically signifies either a fault in the wiring or the ECT sensor itself, which may lead to malfunctioning engine performance or increased emissions. Identifying and resolving this issue is crucial for the longevity of the vehicle and the efficiency of its engine operation. The DTC P0119 describes a malfunction in the ECT Sensor 1 circuit, which monitors the temperature of the engine coolant. It plays an essential role in helping the PCM, or Powertrain Control Module, effectively manage the engine function, including fuel injection and ignition timing, based on coolant temperature readings. The ECT sensor is situated near the thermostat housing in the engine bay for optimal monitoring of coolant temperature as it circulates through the engine. When the sensor fails, or if there's an issue within the circuit, it can negatively affect engine performance and fuel efficiency, potentially causing engine overheating or poor cold start performance. The circuit being out of range suggests an issue, typically electrical in nature, which can stem from wiring problems, bad connectors, or a faulty sensor itself. Addressing this issue promptly ensures that the engine operates within the optimal temperature range, thereby prolonging its lifespan. Several potential causes may trigger DTC P0119, beginning with the possibility of a faulty ECT sensor. If the sensor is damaged or malfunctioning, it will send incorrect temperature signals to the PCM, causing the circuit to be recognized as out of range. Another common cause is shorted wires, which can occur through wear and tear, corrosion, or exposure to extreme temperatures or substances. This can create a false reading for the circuit, thus triggering the fault. Open wire issues may also arise, preventing the proper transmission of signals between the ECT sensor and the PCM. These wiring issues can result from physical damage or poor connections at the terminals. Identifying the root cause is essential for an effective repair, ensuring the reliable functionality of the engine cooling system and overall engine performance. The symptoms associated with DTC P0119 can manifest in several ways, primarily through the illumination of the check engine light on the dashboard. This warning alerts the driver to a potential issue within the engine's management systems. Additionally, if the engine coolant temperature is not accurately monitored due to a faulty ECT sensor, there may be risks of engine overheating, which can lead to severe engine damage if left unaddressed. The vehicle may also experience poor fuel efficiency because the PCM relies on accurate coolant temperature readings to adjust fuel delivery appropriately. Symptoms may also include rough idling or fluctuating engine performance as the vehicle struggles to adapt without reliable temperature data. It's essential to closely monitor these symptoms and address any discrepancies to ensure optimal engine performance and prevent further issues. The first step in troubleshooting DTC P0119 involves verifying the problem through practical checks. Start by turning the vehicle to the on mode, which is crucial for the diagnostic tool, Honda Diagnostic System, HDS, to properly communicate with the vehicle's onboard diagnostics. Next, clear the DTC using the HDS, allowing the system to reset its error codes. Once cleared, start the engine and hold the RPM at 3000 without load until the radiator fan activates. This step helps test the system and confirm if the fault persists under specific conditions. After allowing the engine to idle down, check again for pending or confirmed DTCs with the HDS. If DTC P0119 reappears, the issue is confirmed, indicating a likely fault in the ECT sensor circuit. If it does not reappear, you may be dealing with an intermittent failure, suggesting further investigation is necessary into connections and terminals. In the second troubleshooting step, begin by turning the vehicle to the off/lock mode, which is essential for safely performing electrical checks. Use the HDS to jump the SCS line before disconnecting critical components, including the ECT Sensor 1's 2P connector and the PCM connector number 1, 96P. With these components disconnected, you will check for continuity to determine if there is a short in the TW line. The test should be conducted using the vehicle in off mode for safety. By connecting your test equipment to the ECT Sensor 1 connector's female terminal number 2 and body ground, you can establish continuity between these points. If continuity exists, it confirms a short in the TW wire between PCM connector number 1, terminal 49, and the ECT sensor. If there is no continuity, there may not be any short, and you will need to proceed to inspect for open wire issues in the next step. Now, moving on to the third troubleshooting step, it is again vital to check continuity between specific test points while ensuring the vehicle remains in the off/lock mode and the connectors are still disconnected. By checking continuity between the ECT Sensor 1 connector's female terminal number 2 and PCM connector number 1, terminal number 49, you can confirm the integrity of the TW line. If continuity is confirmed, it indicates that the TW wire is functioning correctly, meaning you should proceed to the next step to investigate further. Conversely, if the test reveals no continuity, it suggests there is an open in the TW line that must be addressed. This may involve inspecting the wiring for any physical damage or loose connections, preventing proper communication between the ECT sensor and the PCM. You can resolve this by repairing any breaks or disconnections to restore functionality. In the fourth troubleshooting step, once again, it is crucial to check for continuity, but this time, focus on the SG3 line. With the vehicle still in the off/lock mode and both connectors disconnected, check continuity between the ECT Sensor 1 connector's female terminal number 1 and PCM connector number 1, terminal number 91. If continuity exists, it means the SG3 wire is functioning properly. Consequently, the next course of action would be to replace the ECT Sensor 1 itself. If continuity is not confirmed, then an open exists in the SG3 line that must be repaired to ensure proper signal transmission. This step emphasizes the importance of electrical integrity in the vehicle's monitoring systems. Resolving these issues ensures the ECT sensor can communicate effectively with the PCM, thereby maintaining the vehicle's performance and efficiency. Final repair verification for DTC P0119 is crucial to ensure that the issue has been successfully resolved. Begin by clearing the DTC using the HDS to reset the vehicle's diagnostic system. After clearing the code, perform a test drive under various conditions to assess whether any symptoms reappear. During the test drive, monitor the vehicle's performance closely, specifically looking for any resurgence of the check engine light or engine temperature discrepancies. It's essential to confirm that the ECT sensor is now functioning within a normal range and that all systems are operating effectively. If no DTC reappears and the vehicle performs well, then the repair is deemed successful. This final verification ensures that the earlier troubleshooting steps effectively address the original fault, restoring optimal engine function. Preventive maintenance is essential in ensuring the longevity and reliability of vehicle components, particularly concerning the ECT sensor and its wiring. Regularly inspecting the wiring for the ECT sensor can help identify potential issues before they escalate into significant problems, such as shorts or opens. Cleaning the ECT sensor connectors and ensuring they are not corroded can also enhance performance reliability. Corrosion can lead to poor connections that manifest as DTCs. Additionally, periodic checks of the ECT sensor's condition itself, including its mounting and any physical wear, will ensure its functioning optimally. Training in recognizing early warning signs, such as fluctuating engine temperature readings or unusual engine performance, will enhance maintenance effectiveness. By staying proactive with these maintenance efforts, drivers can reduce the likelihood of encountering faults like DTC P0119. In conclusion, encountering DTC P0119 signifies a disruption in the function of the ECT sensor circuit, which plays a crucial role in engine management. Diagnosing wiring integrity and the sensor itself is essential to resolving the issue effectively. By following the outlined troubleshooting steps and ensuring continuity checks are met at each segment, you can accurately pinpoint faults that may lead to the DTC. Regularly performing maintenance on the ECT sensor and associated wiring can greatly reduce the chances of similar issues arising in the future. Taking these preventative measures ensures that the vehicle operates at peak performance, minimizing the risk of engine overheating and maintaining optimum fuel efficiency. Awareness of this DTC and proactive management contributes significantly to the health and longevity of the vehicle. Please like and subscribe to the channel. See you next time.